Well, let me tell you, it's a privilege to be here in Roswell, New Mexico, and I sure appreciate the turnout, knowing that there's so many competing things to do here. We're going to have an interesting day today because we're going to try to cover a great deal of material. At the same time, while many of us are drawn by curiosity, many of us are drawn by urgent needs, because there are many hurting people that are in some way involved with some of the strange goings-on. So we're going to talk about today a Christian perspective of UFOs. What we're going to do today, this morning, I'm going to try to lay some foundations. Now, one of the things that's going to come up, and I wanted to lay the groundwork right up front in this conference, is the nature of reality as we understand it from modern science, to take advantage of a message that we're in possession of that we can prove and demonstrate. So fasten your seatbelts. One of the things that the secular researchers have concluded about the UFOs, now let's just cut through this. We're here at Roswell, so many people here obviously come here with all kinds of presuppositions. It doesn't take any insight to realize that the whole UFO area is full of hoaxes, nonsense, and foolishness. And indeed, many people are here in Roswell just in good-natured kidding and having fun. But when you strip away the hoaxes on the one hand, and when you strip away the deliberate disinformation by some very well-resourced groups on the other hand, what you have left is disturbingly real. There are occasions where these UFOs are confirmed. They're tracked on radar, leave radiation behind. They're tangible on the one hand. And on the other hand, they behave in ways that totally defy our perception of physical laws. There are many people that presume that they are from some other galaxy or in some outer space context. However, those of you that have done serious research in this area know that the most competent researchers in this area, people like J. Allen Hynek, who passed away a few years ago, and Jacques Vallée and others, have come to the conclusion they're not from some other galaxy, they're from another dimension within our own. And so one of the things we want to talk about, that's strange talk, and we can glibly use cliches without really understanding what they mean, drawn either from science, mathematics, or even the Bible, and use them rather glibly. We want to cut through that a little bit and lay some foundation. So I want to talk a little bit about hyperspaces. Now, the trouble with hyperspaces, there's only two kinds of people that seem to be able to reasonably deal with hyperspaces. Mathematicians that have special training, or small children. They have no problem with this, really. Now let's back up and talk with Euclid. Euclid's writings are probably the most widely circulated and popular for the last 2,000 years, second only to the Bible. And I'd like to just talk a little bit about trigonometry. Let me ask you a question. How many of you know how many degrees are there in a triangle? If I take a triangle, typically say a 30, 60, 90 triangle, and add up the degrees, it adds up to what? 180 degrees, exactly. If I take a 45, 45, 90 as another example, again, the angles of a triangle add up to 180 degrees. That's how many knew that? Okay, good. Well, suppose Dr. Eastman and I walked out into the large desert area out here and laid out a very large triangle. And as we compared our calculations, we discovered that our angles added up to more than 180 degrees. What would you conclude? That we screwed up again. What you'd expect from Chuck and Mark, right? No, if we have a triangle that adds up to more than 180 degrees, and we check our figures, it's accurate, what have we encountered? The curvature of the earth, exactly right. In other words, a third dimension. See, these little rules that we learned in school have to do with plane geometry, a geometry of only two dimensions. If you take a course in navigation, you encounter spherical trigonometry where you can have a triangle with 90 degrees in each corner. And again, this is a way that we encounter an additional dimension. A three-dimensional triangle obviously can have, in fact, that's how you know it's three-dimensional, if it violates that original geometry. Now, that's the kind of insight that led to Dr. Einstein's solutions as he grappled with the nature of our reality. Most of you know that in 1905, he had a special theory of relativity in which length, mass, and velocity and time are relative to the velocity of the observers, the famous initial step at this. And it was a few years later that he generalized this theory, and he discovered that there really is no distinction between time and space. If you're really properly briefed, you will always speak of space-time. We don't do that. We're comfortable with three spatial dimensions and time. We treat them separately. But we know in modern science that we live in at least a four-dimensional continuum. And by the way, this has been confirmed 12 different ways to 5 decimal places and beyond. In fact, I understand recently an experiment confirmed it to 14 decimal places. So the point is, they're really, while we call it the theory of relativity, it's far more than a theory, it's well confirmed. Now, this leads us then into the whole area of hyperspaces. You and I would tend to be most comfortable at visualizing this as 3 spatial dimensions, length, width, and height, and time. But time itself is a physical property. And in particle physics today, if you're current in reading particle physics, you know that they have concluded that we actually live in 10 dimensions. And it's interesting that that was perceived by the ancient Hebrew writers from Genesis chapter 1. But rather than do our homework in Genesis 1, we've spent billions of dollars on accelerators to determine it the hard way. But in any case, now the reason we're getting into this today is I think it's going to be useful for at least to consider the possibility that these UFOs, and more importantly, their occupants and whatever, are coming to us not from some far galaxy, although they seem to be posing as if they are, but they come from another dimension, and that has profound implications for you and I. Now, we have trouble going up in dimensions. If I start talking 4 or 5 dimensions, you and I will be at a loss because we're not specially trained in that way. But we can gain some insights by imagining something less than 3 and drawing some inferences. Let's imagine a world that has only 2 dimensions, like a plane. Let's imagine in our imagination that there are occupants with 2-dimensional occupants within that 2-dimensional plane. Now, if we came along as a 3-dimensional person and put our finger through that plane, what would the 2-dimensional people in that 2-dimensional world observe? A circle. Or a hole, yes, in a sense. Right, exactly. Let's take another example. If a 3-dimensional sphere is passing through that 2-dimensional universe, it will appear as a point that enlarges to a circle and then that reduces back to a point. Because they would be perceiving a 2-dimensional slice of that 3-dimensional object passing through. Are we together? Now, let's assume we didn't have a circle, we had some other kind of an object, here represented such as a cube. If that cube tumbles through that space, not only will it start from a point and get big and then shrink, it will change shape as it goes through, and depending on how it's being cut by that plane. Are we together so far? There are many. Jacques Vallée, who's probably one of the most prominent published people in the UFO area, has suggested that these UFOs may be windows into another dimension more so than objects. And you and I have a tough time relating to that, but he may be very, very correct. Let's assume that we were trying to communicate a 3-dimensional object to a 2-dimensional world. We would be asking that 2-dimensional world to encounter things that they don't encounter in their experience. Our imaginations are generally limited to our own experiences. One way we could try to do it if we had a cube would be to project that 3-dimensional image into a 2-dimensional space and maybe rotate it, but its behavior in the 2-dimensional space would be bizarre to the 2-dimensional occupants in any case. Now, another way we could do that would be to take a 3-dimensional cube, say, and unravel it into 2 dimensions. And we would take that 2-dimensional cube and start to unfold it and lay it out flat. And that would be a way, possibly, to try to get a 2-dimensional being that we're communicating with to recognize what a 3-dimensional cube might be. But all of these are very imperfect because we're asking that 2-dimensional being in a 2-dimensional world to extend their concepts into a dimension, into a region that they have no experience with. Now let's take another example, and that is there are such things as hypercubes, a 4-dimensional cube. How do I represent a hypercube in the 3 dimensions? One way is to unravel it, and one suggestion is what's called a Hinton cube, which is an unraveled Hinton cube or a hypercube called a tesseract. And even you and I look at that and have a tough time trying to relate to a 4-dimensional cube. You say, well, what practical use? Interestingly enough, Salvador Dali used that tesseract, a 4-dimensional cube, in his famous painting of the crucifixion. And we'll come back to some of these issues a little bit later. What we've done here, in just a little tentative exploration, is go beyond Euclid. And we like to talk about more than 3 dimensions, hyperspaces. It turns out the most important lecture ever given in history, history of mathematics, occurred in June of 1854, when George Riemann, who was a pastor's son, by the way, developed a set of mathematics, metric tensors, that opened our thinking to be able to represent meaningfully hyperspaces, spaces of more than 3 dimensions. And it took about 60 years later that Einstein, exploiting those concepts, developed his 4-dimensional space-time. Now, the irony of Einstein's life is he went to his death frustrated by not being able to relate gravity and light into that region. And it was actually in 1953 that Kaluza and Klein together developed, by extending another dimension. Light is basically a vibration in 5 dimensions. Light and supergravity have been integrated by the Kaluza-Klein models, which are basically extending this 4-dimensional space into more than 4, 5, 6, and so forth. And in 1963, the Yang-Mills fields, extending it even further, have integrated electromagnetic and both the nuclear forces, both the strong and the weak nuclear forces, for those of you that are familiar with physics. There are 4 basic forces in the universe, and 3 of the 4 have been integrated by the techniques. Now, the current thinking from about 1984 on is that the universe actually consists of what the mathematicians called superstrings, and that they actually involve 10-dimensional mathematics. Now, it's not our purpose here to get into this area, because there's 2 kinds of people in the audience, those that are familiar with this and those that already have learned more than they really want to know about hyperspaces. But I want to mention this because there seems to be good evidence from the reports that these encounters that are going on involve hyperspaces. These UFOs and their occupants not only are clocked on radar and elsewhere at making right-angle turns at speeds that are incredible, which imply they're massless by our physics. They also go faster than the speed of sound without sonic booms, and that's a disturbing thing. But what's most disturbing is they seem to have the ability to materialize and dematerialize at will. And that disturbs us. It makes them seem very, what we would use the term supernatural. But that supernatural term may be derived only because of our limited understanding of nature. And let's move on a little bit. I want to cover something else because it's going to be very important for you and I as an opportunity to validate a message. And I want us to shed some baggage that we tend to carry with ourselves about this strange dimension called time. You and I tend to presume that time is linear and absolute. We assume that an hour yesterday is like an hour a year from now, and that there's really no discernible difference. We also think of time as linear. And when we were in school, the teacher would draw a line on the blackboard, and it would start, the left end would be the beginning of something, the birth of a person, the founding of a nation, or some such thing. And the right end of the line might be the death of that person or the termination of that empire, what have you. We've made timelines. How many of you have made timelines in school? Well, how many of you went to school? Okay, that's right. Well, because of this idea, when we encounter the concept of eternity, we jump to the model in our minds that eternity is sort of like a line that starts at infinity on the left and that goes to infinity on the right. That's a natural extrapolation from our own experience. Therefore, when we encounter something like God, we think of someone who has lots of time. And that turns out to be bad physics. Because God is not, see, time, we've learned from Einstein, is a physical property. And let's explore that a little bit, because that's important. We exist in more than 3 dimensions, and time itself is a physical property. Time, we know, varies with mass, acceleration, and gravity, just to name a few. And let me demonstrate that for you. If I had an atomic clock here on the platform and I raised it 1 meter, it would speed up by 1 part in 10 to the 16th. Not enough to adjust our personal schedules, obviously, but the point is predictable and measurable. If I raise it 100 meters, it would speed up by 1 part in 10 to the 14th. Now, the United States Naval Observatory actually conducted an experiment in 1971. Put an atomic clock on an airplane, went around the world eastward. Compared to an atomic clock at rest at the observatory, it lost 0.06 microseconds. They put one on an atomic clock going westward around the world, and it gained 0.27 microseconds. Not a lot, but the point is, by accounting for all the variables, that's exactly what Einstein's theory would predict, and that's exactly what they experienced. The point is, time is a physical dimension. Let me give you another example. If you read a physics textbook in this area, you'll almost always encounter a hypothetical example of the 2 astronauts. And we imagine 2 astronauts born at the same instant, and we're going to send one of them to the nearest star, which happens to be Alpha Centauri, about 4.5 light years away. If you apply the Lorentz transformations here, it turns out, and we're going to send this guy, the guy's traveling, to Alpha Centauri at half the speed of light and then bring him back. Alpha Centauri being 4.5 light years away, going at half the speed, take him 9 years to get there, 9 years to get back. But when he gets back, he will discover that he's not 2 years and 9 months younger than his twin brother. If that doesn't bother you, you weren't listening, okay? Let me dramatize it a little further. Let me imagine that it were possible to send him at 99.99% of the speed of light. It would take him 9 years to make the round trip, but during that time, the Earth will have aged 636 years. That should bother you. Now, don't quarrel with the arithmetic. The point is that time is a physical property, and that has some profound implications for you and I. Albert Einstein summed it up very nicely. He said, people like us who believe in physics know that the distinction between the past, the present, and the future is only a stubbornly persistent illusion. Let's imagine some being is outside our dimensionality of time, and in our dimension of time, we have the past, the present, and the future as we experience it going through this line, right? Now, an analogy here would be like the parade that's going on right now through Roswell. If you're sitting on the curb watching these floats come around the corner, for you on that curb, that parade is a linear sequence of events. But if you are outside the plane of that parade, say in a helicopter above the parade, you can see the beginning at the end at the same instant. That's a clumsy analogy, but I think you get the idea. Now that means that even though for us it's past, present, and future, from someone in eternity who can watch the past, the present, and the future, it's in common, so to speak, for the one in eternity.